Hey there, science fans! Welcome to another exciting episode where we dive into the fascinating world of helicopters. Today we're talking about helicopters, those amazing machines that can fly straight up, hover in midair, and even fly backwards. These versatile aircraft are used in a variety of fields, from search and rescue missions to transporting goods and people, and even in military operations. Ever wondered how they do it? And it all comes down to those spinning blades called rotor blades. These blades are the heart of the helicopter, allowing it to perform such incredible maneuvers. Rotor blades are like long, skinny wings that spin around really fast. When these blades rotate, they create lift, which is the force that allows the helicopter to rise off the ground. Each blade is an airfoil, a special shape that generates lift as it moves through the air. The design of the airfoil is crucial because it determines how efficiently the blade can produce lift. Think of it like throwing a frisbee. The shape makes it fly. Just like a frisbee, the rotor blades have a curved shape that helps them cut through the air and generate lift. Now, you might think all parts of the rotor blade generate the same amount of lift, right? But that's not the case. The lift generated by the rotor blade varies along its length. The tips of the blades move faster than the parts closer to the hub, creating more lift at the tips. This difference in lift is what allows the helicopter to maneuver so precisely. Let's explore this further and see how these differences in lift are managed to keep the helicopter stable and controlled. Here's the thing about helicopter rotor blades: they don't generate lift equally across their entire span. This phenomenon is called unequal rotor lift distribution. Imagine the rotor blade spinning like a giant propeller. The part closer to the center, called the hub, isn't moving as fast as the tips way out at the edge. Since lift depends on speed, the faster moving tips generate more lift than the slower moving sections closer to the hub. This creates an imbalance of forces that engineers need to address. So why do the faster moving rotor tips generate more lift? It all boils down to air pressure and speed. Remember that airfoil shape? As the rotor blade spins, air flows over both the top and bottom surfaces of the airfoil. The shape forces the air flowing over the top to travel faster than the air flowing underneath. Faster moving air creates lower pressure, and slower moving air creates higher pressure. This difference in pressure creates lift, pushing the blade upwards. Since the rotor tips are moving faster, they experience a greater pressure difference and therefore generate more lift. Section 4. Stresses and strains. The downside of uneven lift. Now, this unequal lift distribution isn't just an interesting physics quirk. It can cause some serious problems if left unchecked. Helicopters rely on their rotor blades to generate lift and keep them airborne. When the lift is unevenly distributed across the rotor blades, it can lead to a host of issues that compromise the safety and performance of the aircraft. Think about it. If one part of the rotor blade is generating way more lift than the other, it puts a lot of stress on the blade and the entire helicopter structure. This stress can manifest in various ways, such as bending or twisting of the blades, which can further exacerbate the problem. Over time, the continuous strain can lead to material fatigue and eventual failure of the rotor blades. This can lead to vibrations, instability, and even catastrophic failure if not properly addressed. Vibrations are particularly concerning because they can affect the entire helicopter, making it difficult for pilots to control the aircraft. In severe cases, these vibrations can cause components to loosen or break, leading to a loss of control and potential crashes. That's why helicopter engineers spend a lot of time and effort trying to mitigate the effects of unequal lift distribution. They conduct extensive research and testing to understand the dynamics of rotor blades and develop solutions to ensure even lift distribution. This involves using advanced materials, innovative designs, and precise manufacturing techniques to create rotor blades that can withstand the stresses and strains of flight. They've come up with some ingenious solutions, from adjustable rotor blade angles to sophisticated computer systems that monitor and adjust lift in real time. These innovations have significantly improved the safety and performance of helicopters. By addressing the issue of uneven lift distribution, engineers have made it possible for helicopters to fly more smoothly and reliably, ensuring the safety of both pilots and passengers. Section 5. Engineering solutions. Taming the unequal lift beast. One of the key ways engineers deal with unequal lift distribution is through a technique called washout. Washout involves twisting the rotor blade slightly along its length. The angle of attack, that's the angle at which the blade meets the oncoming air, is reduced towards the tips. This reduction in angle of attack at the tips reduces the amount of lift generated in those areas, helping to even out the lift distribution across the entire blade. Pretty neat, huh? Section 6. Compromises in design, balancing act of twist and taper. In the world of helicopter engineering, achieving the perfect balance between twist and taper in rotor blades is a complex yet fascinating challenge. This balance is crucial for optimal performance and safety. Another technique used to combat unequal lift is varying the airfoil cross-section along the blade's length. This method helps in distributing the lift more evenly across the rotor blade, which is essential for stable flight. Engineers meticulously design the airfoil to ensure that it performs efficiently under different flight conditions. Remember how the airfoil shape is crucial for generating lift? The shape of the airfoil determines how air flows over the blade, creating the necessary lift to keep the helicopter aloft. By adjusting the airfoil shape, engineers can control the lift generated at various points along the blade. By making the airfoil thicker near the hub and gradually thinner towards the tips, engineers can further fine-tune the lift distribution. This gradual change in thickness, known as tapering, allows for a more efficient lift generation, especially during different phases of flight such as takeoff, cruising, and landing. This is because a thicker airfoil generates more lift at lower speeds, while a thinner airfoil is more efficient at higher speeds. However, there are compromises. The design must account for the varying aerodynamic forces that act on the blade at different speeds and altitudes. High twisting can weaken the blade. When a rotor blade twists too much, it can lead to structural weaknesses, making the blade more susceptible to damage and reducing its overall lifespan. Engineers must carefully calculate the optimal amount of twist to ensure durability and performance. Similarly, excessive tapering can reduce the blade's overall lift. If the tapering is too pronounced, it can lead to a decrease in the blade's ability to generate lift, especially at the tips where it is needed the most. This can compromise the helicopter's ability to perform maneuvers and maintain stable flight. It's all about finding the right balance. Engineers must strike a delicate balance between twist and taper to optimize the rotor blade's performance. This involves extensive testing and fine-tuning to ensure that the helicopter can operate safely and efficiently under a wide range of conditions. The art and science of helicopter blade design is a testament to human ingenuity and the relentless pursuit of perfection in aviation. Section 7, conclusion, the quest for equilibrium in the air. So there you have it, the science behind unequal rotor lift distribution in helicopters. It's a complex issue that requires careful engineering to overcome. By using techniques like washout and varying airfoil cross-sections, engineers can create helicopters that are both safe and efficient. Next time you see a helicopter soaring overhead, remember the intricate dance of forces happening above and appreciate the sheer ingenuity that makes it all possible.